So we have this. We want to calculate the mean h. So the mean is given by sigma fx over sigma f. So we have 15 times 5 plus 16 times 6 plus 17 times 3 then plus 18 times 1 all over 5 plus 6 plus 3 plus 1. So we simplify this to obtain something like this: 75 plus 96 plus 51 plus 18 all over 15. So if you need tutorials on any topic, you can always contact me or join my online class for help. So that is 16. Now we have, that's the solution for question 26. Now let's look at question 27. We are looking for the median. So we need to find half sigma f plus 1 value, the value that is in that position. So this gives us 1 over 2 into bracket 15 plus 1 value. So that is 16 over 2. So that is 8 value. So from the left and from the right, the median is 16. So we have this. We have x equal mn over 3, equation 1. We have m equal v over y. Let's call this equation 2. So we just put equation 2 in equation 1. Then we obtain something like this: x equal v over y times n all over 3. So we just simplify this. We get x equal vn over y all over 3. So it is same as v over y divided by 3. So we have vn over y times 1 over 3, which is vn over 3y. Now we have this and we want to find m in base 6. So m base 6 is equal to 1, 2, 3 base 5. So what we do is to convert 1, 2, 3 base 6 to base 10, then convert it back to base 6. So converting from base 5 to base 10, we have something like this. We get 25 plus 10 plus 3. So this gives us 38. So now we convert 38 to a base 6 numeral. So we use repeated division. So 6 goes into 38 6 times, which is remainder 2. Then 6 into 6, 1, remainder 0. 6 into 1 cannot be possible. So we have 1, 2, 3 base 5 is equal to 1, 0, 2 base 6. Hence m equal 102. Now we have this. So we're given the triangle. The triangle is given by this x, z, x, y. So we were told that z is equidistant from x and y, and x, y is 8. So we were told that the distance from z to x is 5. So this is an isosceles triangle. So this is 5 centimeters. So we can now determine the height. This is 4, and from Pythagoras theorem we can find the height. So we know 5 squared equals 4 squared plus absolute value of zn squared. So we solve for zn to obtain the square root of 25 minus 16. So this gives us root of 9, which is 3 centimeters. So now we can now calculate the area, which is half base times height. So half times 8 centimeters times the perpendicular height, which is 3, and this will give us 4 times 3, which is 12 centimeters squared. So we have this. Now the volume of a sphere is given by 4 over 3 pi r cube. So we just sub in the values. So we have 4 over 3. The diameter was 6, so the radius will be 6 divided by 2, which is 3. So we just sub in that over here. So if you sponge this or simplify this, we are going to get, so you can always contact me for more tutorials, detailed one of course, step by step. So 113.14, and to the nearest whole number is 113 centimeter cube. So we have this. Calculate the total surface area of a cuboid is given by 2 times length times breadth plus length times height plus the breadth times the height. So we just sub in these values. So 12 by 8 plus 12 by 3, then plus 8 by 3. Then we simplify further to obtain something like this. 96 plus this is 36 plus 24. So this is 2 times 156, which is 312 centimeter. Now we have this one. Vertical opposite angles are equal. So y equal 43 degrees. And over here too, the angle at the sector is twice the one at the circumference. So we use the sum of angles in a triangle, the isosceles triangle, to obtain the value of x. So we solve for 2x to obtain 2x equal 180 minus 86, which is 94. So we divide both sides by 2 to obtain x to be equal to 47 degrees. Now we are looking for the nth term. So a is half, and the common difference is 1 over 4 over 1 over 2. And this gives us 1 over 4 times 2 over 1, which is 1 over 2. We just sub them in and use our knowledge from indices to simplify. So we obtain something like this. So we use the knowledge from indices. So this is 2 to the power 1, and this is, we share the exponent for them. We have 2 to the power n minus 1. Then this one will be the same as 1 to the power n minus 1. So 1 to any power is the same as 1. So this gives us 2 to the power 1 plus n minus 1. So we get 1 over 2 to the power n. And this one, so this is a cyclic something, it's like modulo. So he went for walking on Wednesday. So we have 1, 2, 3, 4. So the 5th day is this, and the 6th day will be Tuesday. So that's it. Now we have this. We are supposed to estimate the interquartile, which is the third quartile minus the first quartile. So you know the formula already. We'll find interquartile rate is given by this. So the third quartile is 3/4 total frequency, the value in that position, minus 1/4 the total frequency, the value in that position. So just simplify and trace from the graph. So this is, the total frequency is 50. So 3 over 4 times 50, the value in that position, minus 1 over 4 times 50, the value in that position. So we get 37.5 value minus the 12.5 value. So we trace that from the graph, and the 37.5 value will correspond to the 3.2 mark. Then that of 12.5 will correspond to 2.45. So subtract this and we obtain 0.75. And this one, we want to find how many customers wanted at least 3 minutes, so we trace 3 minutes to this, and it is corresponding to 31. So the number who want at least 3 minutes is 31. 50 minus 31, which is 19. Now we have this over here. So to look for the coefficient of x, we just multiply these two terms because they are the one that will give us the coefficient of x, which is 0. Then we have this, we are looking for the quadratic equation, so we use a factor approach and work backwards. So you know this can be rewritten as 2x equal 1, and this one too is 2x equal negative 3. So we can rewrite this as 2x minus 1 equals 0, or 2x plus 3 equals 0. So we just cross multiply or multiply the factors and equate to 0, because we are just working backwards. When we do that, we obtain something like this, and we expand now to get 4x squared plus 6x minus 2x minus 3 is equal to 0. So this gives us 4x squared plus 4x minus 3 equals 0. We have another approach too, but we'll use it in another example.